Load balancing is great and all, but say we encounter a different scenario. Let's say that you have two servers, server A and server B, and a network that has two connections to different ISPs, ISP A and ISP B. Now, ISP A is very expensive to use, but it is super reliable, and this is a path that you want to use for priority traffic coming from server A. Whereas ISP B is not as reliable, but it is cheap. This is where you want the traffic from server B to go. In this scenario, this is where we would use filter-based forwarding. This allows a router to forward packets using a match filter, which classifies traffic based on certain criteria, such as the source IP address. Now, remember that the default action for traffic passing through a firewall filter is to discard, so we must also account for all other non-specified traffic. After creating our match filter and applying it inbound on the correct interface, we will configure two separate routing instances, one to send traffic to ISP A and the other to send traffic to ISP B. Finally, we will create a RIB group so that we can share interface routes between the new routing tables. Filter-based forwarding is probably the topic that most students find the most difficult, but actually it's not that difficult if we break it down into its component parts. So let's have a look at our topology. This is our topology. We have server A, server B, with a final destination of 172.20.2.2, and we want server A traffic to pass through ISP A and server B traffic to pass through ISP B. Now what I'm going to do, I will probably make all of these, sorry, not including the switch because the switch is only layer 2, but up to VMX1 R1 with all of its interfaces in OSPF area 0, and then the default route from server A and server B going to the respective interfaces on VMX R1. And on VMX R1 GE002 there will be two separate IP addresses. I will use the IP range of the 12 range, probably 12.1.1 and 12.2.2 for server B.
If you're enjoying the content, please consider subscribing, as 86% of viewers aren't currently subscribed.
So let's do that now. First thing I'll do, I'll jump onto VMX R1 and do that interface configuration. Alright, so those interfaces have already been configured on VMX R1. Let's have a look on the servers. So server A currently has no IP address. Oh, it's been given a default 169 address, is no good for us. So let's do that, configure this IP address. And server A will be 12.1.1.2 with a 24-bit subnet mask. And its default gateway will be 12.1.1.1. Okay. And let's do the same for server B. .2.2.2. .2.2.1. Not responding. Not good. Alright, let's see if it actually took that configuration. No, it did not. Alright, let's do this again then. Yeah, we've got that. Let's see if we can ping, which we can. We also need a default route, so route add going to 12.1.1. Oh, sorry, we're on route on server B, so 12.2.2.1. See if that's in our routing table, which it is. And let's do the same for server A. Okay, so server A already has it, so 12.1.1.1. That's our gateway, yeah. So that's our default route, which is there. Let's see if we can ping. Excellent. All right. Connectivity to VMX1 and prefixes beyond that has been established. Now let's do the configuration on VMX1. And as I said, I'm just going to advertise everything to OSPF. So edit protocols, OSPF area 0. Now this you probably wouldn't see in the real world. You probably would have BGP connectivity or a static route between your network or the local network and an ISP network. But just for the sake of this lab, we're going to use OSPF for reachability. And we're going to advertise all of our interfaces. So set interface all. We're going to make it point to point. Now the only reason I'm using point to point here is because I'm not looking to do any DR or BDR election, but we will cover that in the next section when we get into OSPF. I might as well copy this command because I'm going to be doing that on all of the other devices as well. So ISPB first. Edit protocols, OSPF area 0. Let's commit that. ISPA next. Edit protocols OSPF area 0, and I'm presuming that the interfaces have already been configured for reachability according to the diagram, but we will check that. And the last one is VMX2. Commit that. Run show OSPF neighbors. Okay, so this one is in Xstart. We just caught it in time, but the other one has already transitioned to full. And run show OSPF interface, even though we don't really need that because we can see this here. So these interfaces are point-to-point interfaces. I would have expected to actually see the loopback advertised here as well. But if I just go into ISPA and do a run show route for the protocol of OSPF. Oh yeah, so we see the 172.20.2 network is here. Alright, so in regards to reachability, actually, let's go on to server A and first, let's see if we can ping 172.20.2.2, which we can. And let's see which path through the network this server takes to get to that 172.20.2.2 network. So server A is taking this path, so it's getting to VMX1, going up to ISP A and coming out this way. And let's do the same check on server B. And actually server B is taking the same path, coming up here, going up to server A, which is 10.1.0.2, and coming down here and coming out. And we can see that through the trace route, 10.1.0.2. And the reason we're actually doing this whole filter-based forwarding is that we want to change that. So we want server A to have the 10.1.0.2 network in its trace route, but server B should have the 10.1.0.6 network when we do its trace route by the time we're finished. And there are three things that how we're going to do this. So first we're going to create and apply a match filter. Then we're going to create routing instances. And the third one is we're going to do some RIB groups to share the routes between the routing instances. And all of the intelligence of this is going to be done on VMX R1. Nice, okay. What I want to do, I just want to clear this screen, make it fresh. Alright, let's begin. So the first thing I want to do is match those interfaces, and this is going to be done under a firewall filter. So edit, firewall, family. For the layer 3, which is an INET, that's why we're doing IP addressing, filter, and we're going to call this, let's just pretend that server A and server B are customer servers. So let's call them customer servers. And the first term, set term, is going to match, actually we will call it that, so match server A subnet. This is our first term. Then, let's say from the source address of 12.1.1.0/24, it's going to be the same term. Then we're going to send it to the routing instance, which is going to be called ISP A. Good. And we're going to do the same for B. So for our subnet now is 12.2.2, and we're going to change our term to say server B. If we up arrow, we're going to send it to routing instance ISP B, and for our second term. Alright, let's show that. So from this source address, now you see here it says that routing instance ISPA is not defined, and this is not an issue, and also ISPB is not defined, and this is something we have to make sure that we do. But before I do that, I'm going to apply this match filter, and we know that from the diagram it's coming in on GE002, so we're going to do a input filter. So edit interface GE002.0 for family INET. Set filter input, and it was called input customer servers. So we've created our match filter, and now we've applied it to the interface on the inbound direction. The next thing that I'm going to do is create the routing instances. Edit routing instances. Set ISPA, and our instance type is going to be the simplest one, which is, instance type is forwarding. And we're going to set a static route to get to anywhere. We're going to jump to our next hop, which is 10.1.0.2. Now, we know that static routes are not valid if the next hop is not reachable. And for the instance type of forwarding, we can't add any routing protocols and we can't add any interfaces. So for the instance type of forwarding, we're also going to have to do a RIB route to share the direct routes and the local routes into the routing instance. But we'll do that in the next section. So first I've created the routing instance. I've set it as its instance type of forwarding. Now I'm going to set for this routing instance a static route. Routing options. And our routing options are going to be static route of 0/0, which is our default route, with the next hop of 10.1.0.2. Yeah, and we're going to do the same for ISPB. Create a routing option, a routing instance called ISPB, and do a static route with our next hop of .6 instead, and we're going to call it ISPB. So this is step 1 and step 2. Let me just do a commit check on that and see if that's right. Okay, and I will also commit it here. Looks good. Okay, and our final step is to create a RIB group. Now what the RIB group is going to do is going to allow us to share routes between the default routing instance, which is INET0, and our new routing tables, which are for ISP-A and ISP-B. And this is done under the routing options stanza. Edit routing options. Set RIB groups. And I have to create a RIB group name, which I'm going to call FBF RIB group. FBF obviously is for filter-based forwarding. FBF RIB group is my name, and we're going to import those routes into our RIB. Now if we need to list all of our routing tables that we're going to be importing and sharing the routes between, so the first one is INET.0, the second one should be ISPA.INET.0, and the third one should be ISPB.INET.0. Let's commit that. Now we actually have an issue here, and our issue is that if we do a run show route table for ISPA.INET.0, we've got no routes in that table, and the same for ISPB, no routes in that table. And the reason is that, as I said earlier, static routes are not valid if the next hop is not reachable, and the next hop of this one, which is 10.1.0.6, is not actually reachable in this ISPB routing instance. Now to make that reachable, we need the direct route. So we need to take the direct routes from INET0 and share them between these tables. To do that, we will say set interface routes RIB group layer 3 INET RIB group, and then what is the group that all of these are under. We've named that group what has these 3 routing instances as FBF RIB group, was it? FBF RIB group. Let's commit that again. Excellent. Let me just do a check on a couple of these steps. So instance, our routing instance are there, and also I want to do a show firewall family INET filter. Is this it? Okay, sorry. Customer servers, and everything is there. Okay, So this is excellent. So what I'm expecting now is that when I do a trace route from server A, it will go up through 10.1.0.2, and when I do a trace route from server B, it will go through 10.1.0.6. Let's do a check on that now. First one is server A, trace route to 172.20.2.2. Oh, that's just a ping, sorry. I want a trace route, so ping, no, okay, there we go. Looking good for the first one, and let's look for server B. And this one is the one that should change now. So going to 12.1.1. and then to 10.1.0.6 I'm expecting, and then to 172.20.2.2. Excellent. And that's our filter-based forwarding lab finished. It was actually straightforward, as long as you remember that there's 3 steps. Create and apply a match filter, and then to define your routing instances, and then to do a rib group. Thanks for watching this lab, and I will see you in the next one.